Well, I don't really know what that was, but it sounded kind of good. That's how you compose songs, is you really just sort of play around with stuff, and every now and then something good comes out of it. Mathematicians actually kind of do the same thing in a lot of ways, is they play around with things and see where it leads them. So I've always looked at music and mathematics as having lots of parallels to one another, and not a lot of students seem to realize that. So what we're going to be looking at a little bit today is the section on the sum difference identities for the sine and the tangent. So one thing we've looked at so far is we've begun to look at the cosine sum and difference identities. So we're going to look at the sine identities. The structure that I always look at is when we're doing a sine sum identity, I always think of it as going sine, cosine, cosine, sine, same sign. Same thing with the difference identity. Sine, cosine, cosine, sine, same sign. Okay? So again, I just kind of get the little rhythm going in my head because I'm a musician, and rhythms and songs tend to stick in people's heads. So I go sine, cosine, cosine, sine, same sign. And that sticks in my head real well for whatever reason. Okay? All right, so you want to memorize these identities and get the idea of where they come from. I'm not going to do a derivation of these. The derivation is a little more than just straightforward, so you have to work on it a little bit. So one of the things going to look at, if we were dealing with 15 degrees, we would like to look at a combination using some of these special angles, 45, 30, 60, really any kind of an angle that falls on the unit circle that's derived from any of the special triangles. So 15 degrees could be written as 45 degrees minus 30 degrees is one possibility, or it could be written as 60 degrees minus 45 degrees. 75 degrees, what comes to my mind is 45 degrees plus 30 degrees. And what comes to my mind on 105 is 60 degrees plus 45 degrees. So just like when you're dealing with the cosine identity, you have to look for the right kind of combinations on these things. Okay, so we're going to deal with the sine. And what I'm going to do on this one to begin with, so I'm going to write the sine of 75 degrees as the sine of 45 degrees plus 30 degrees. Okay, so we will pull out the identity. The identity goes like this. You do the sine of the first angle multiplied by the cosine of the second angle. Then you use the same sign, the plus sign. Then you do it backwards. You do the cosine of the first angle multiplied by the sine of the second angle. So again, like I said, it's sine, cosine, cosine, sine, same sign. Now we're going to work a little bit with a unit circle like we've been used to doing on these kind of problems. So I'm just going to make a coordinate system here. And we got a 30 degree angle we need to worry about, and we need a 45 degree angle. So on the unit circle, the 30 degree angle has a point square root of 3 over 2, comma 1/2. And the 45 degree angle has a point square root of 2 over 2, comma, square root of 2 over 2, like that. Okay, so when I put this together, of course, the sine is going to be, we know the sine of 45 is the y value. So that's going to be square root of 2 over 2. We know the cosine of 30 is the x value. So that's going to be square root of 3 over 2 also. Okay, then we're going to move on to the cosine of 45, which is the x value. So that's also going to be square root of 2 over 2. And finally, the sine of 30 is going to be the y value at this point. So that's going to be 1/2. So what you're dealing with is the identity in the unit circle. So when we put this together, we're going to have square root of 6 over 4 plus square root of 2 over 4. And then we can write the final answer as square root of 6 plus square root of 2 all over 4. That's the most typical way to write the answer. We also oftentimes write this as 1/4 times the square root of 6 plus square root of 2. I don't really see much need to do that, though. Okay, so here is the final answer of the problem. So just to demonstrate, as I often like to do, is, calculators can be used to check and verify stuff real well in a trig class. So let's see. When I go through and put this together here, now let's see. I've kind of changed up my screen a little bit here today, so I need to scroll this thing down just a little bit here. Okay, clear the screen. And just to show you how this would go is if I was in, of course, degree mode, I want to do that. So if I did the sine of 75 degrees on my calculator, I am going to get this answer. Okay. If I take my answer that I got, the answer that I got was, you'd have to put this in your calculator like this. You'd have to go square root of 6, closing the parentheses. Then you'd have to go like this. You'd have to go plus. Then you'd have to go square root of 2. And then close parentheses and divide by 4. And if you did that, you should get exactly the same answer that we got. Okay, so you can tell by checking your answer on a calculator that this is correct. Okay, all right, let's move on and let's take a look now at the sine of 345 degrees. So again, what we want to do is try to figure out some way on a unit circle, two values we can put together. So one thing that comes to my mind is 300 degrees and 45 degrees. Both of those angles are on the unit circle. So what I'm going to do is I'm going to write this as the sine of 300 degrees plus 45 degrees so that I can utilize this identity. So again, this goes like this. We say the sine of the first angle times the cosine of the second angle. Then we use the same sign, since that's adding angles, we have a plus sign. Then we do it backwards. We say the cosine of the first angle multiplied by the sine of the second angle. And again, we're going to have to pull out the unit circle and consider these two angles on the unit circle, which is a real simple thing to do. Okay, so for 45 degrees, if we have a 45 degree angle, you know basically that goes along with the angle square root of 2 over 2, comma square root of 2 over 2. Okay, that's what you get on that. And then for 300 degrees, of course we're in quadrant 4, but this angle 300 degrees corresponds to this angle, and on the unit circle the x value is small, so that's 1/2. The y value is down far, so that's negative square root of 3 over 2, like that. So all we got to do is just kind of fill in the blanks on this then. So if we're going to do the sine of 300, okay, we just look at the y value. Okay, so that y value is going to be negative square root of 3 over 2. Now the cosine of 45 is going to be the x value at 45 degrees. So that's going to be square root of 2 over 2. That's a pretty easy one to memorize. And then the cosine of 300 degrees will take you back to the x value. So that's 1/2. And then finally, the sine of 45 we know is the y value in the unit circle. So that's also the square root of 2 over 2. Okay, so that's going to leave me with negative square root of 6 over 4 plus square root of 2 over 4. And then I'm going to write this like this. When I get a common denominator, I'm going to put this in this order. It's just kind of a preference. So that would be the final answer of that problem. Okay? One thing that's kind of worth looking at on this problem is you were dealing with the sine of 345 degrees. That's a quadrant 4 angle, and the sine of a quadrant 4 angle gives a negative answer, and this is a negative answer. So by the same argument, you could go through on your graphing calculator and you could easily check that as well. I'm Camtasia. Okay, technical difficulties again. Okay, so I think I've got everything pulled up now. Okay, always a surprise, like I always say on this. Okay, so I'm going to just do a real quick check on my graphing calculator. If I can get it to turn on. Turn on. The on button means turn on. There we go. Good calculator. Okay, so in degree mode, if I do the sine of 345 degrees, I'm going to get this. And notice that's a negative answer. Then on my calculator, I'm going to put in square root of 2 minus square root of 6. Doubling the parentheses, divide by 4. I get the same answer. Okay. All right, so what I'm going to do is I'm going to pause the playback for a few minutes and let you all try number 3. All right, so the first thing that you want to look at this is if you do 180 divided by 12 on your calculator, that'll tell us that we are dealing with a 15-degree angle. Now, there's a couple of ways that you can handle this problem, and you may not do it the same way that I'm going to do it. So what I'm going to do is just start this by looking at this as the sine of 15 degrees. So I think what I'm going to do is I'm going to do the sine of, let's do 60 degrees minus 45. If you didn't do that, you can still get the same answer, okay? So when we do this by the identity, we're going to have the sine of the first angle times the cosine of the second angle. And we're going to use the same sign, that minus sign. Then the cosine of the first angle times the sine of the second angle, like that. So again, it's just kind of a matter of pulling out the unit circle, looking at the key values, okay? You can look these up. I think it's important when you're doing your homework to, instead of always looking at a unit circle, just develop it the way I'm doing, okay? I've got the 45-degree angle is always real easy for students to remember the point. And then this one, I know that it's 1/2 and square root of 3 over 2. I just got to know which is which. Well, since x is bigger than the other x values, that means that's square root of 3 over 2. And since y is smaller than the other two, that's 1/2. So that's the way I always go through personally and reason those things out then, okay? So again, just kind of looking at the same thing, the sine of 60 degrees. Now, why in the world did I do 30 degrees? I need to do 60 degrees, okay? I'm not paying attention. So this point right here is going to be 1/2 square root of 3 over 2, okay? That's what we care about. So the sine of 60 is that y value, so that's going to be square root of 3 over 2. Okay, the cosine is the x value, so that is square root of 2 over 2. The cosine of 60 degrees is the x value, so that's 1/2. And then the sine of 45 degrees is square root of 2 over 2, like that. Multiply together, you're going to get square root of 6 over 4 minus square root of 2 over 4. So we write the final answer as square root of 6 minus square root of 2 over 4 as the answer of the problem. And that's a positive answer. Again, you could check that pretty easily on a graphing calculator. Okay, so let's do that a couple times. I like to kind of do this while I'm doing the recordings to make sure that I'm doing them okay. So again, one thing I'm going to do on this is I'm going to put my calculator in radian mode this time, just for something a little different. And I'm going to enter it the way it was. The problem originally read sine of pi over 12. Okay, so we should get that answer. And again, if we do, you can do this like this. One way to do this is just go, whoops. You want to go parentheses, square root, do it like this. You got to have a set of parentheses, then your square root symbol, square root of 6, close parentheses, minus square root of 2, close parentheses, double up the parentheses, divide by 4, and then that should give the same answer on that. Now, did I end up having something wrong on that? Let's see. Okay, so I think I'm okay on that. I don't know what I was looking at. They're clearly the same answer. I'm just going blind here. Okay, so let's move on. Now let's look at the tangent identities and kind of talk about how they work out. Now, the thing with this is we have two forms of the tangent identity. So the first thing we have is the tangent sum identity, which goes like this. And I always kind of remember it like this, okay? Plus sign there, minus sign there. Okay, same thing here. Minus sign here, minus sign there, plus there. Other than that, they have the same structure. Now, just to mention where these things come from, it's actually a pretty good exercise for a student to do, is if you were developing, and I'm not going to go through the details of this, if I had time I would, but if we wanted to develop this identity, well, one thing you could do is you could do the sine identity, which of course is the sine of the sum is sine alpha, cosine beta, same sign, cosine alpha, sine beta. That is the sine identity. Then the cosine identity is cosine alpha times cosine beta, different sign, sine alpha, sine beta. If you worked with that a little bit, you would end up getting the tangent identity out of that expression. So that's kind of a good exercise to do. All right, so number 4, what I'm going to do is I'm going to start by writing the tangent of 15. Let's write this as 45 degrees minus 30 degrees. There's other ways to do that, obviously, but let's start that way. So when we're doing the tangent difference identity that we're doing here, it says to do the tangent of the first minus the tangent of the second. So we're going to do tangent of 45 degrees minus the tangent of 30 degrees. Of course, this is just unit circle stuff again, all over. And then we do 1 plus, like the identity says. And then we do the product of the tangent of 45 degrees times the tangent of 30 degrees, like that. Okay? All right, so now let's go ahead and let's take a look at a unit circle, and let's look up a couple of things here. Okay, so what we're going to look at is if we have 30 degrees and 45 degrees. 45 degrees, the point on the unit circle is square root of 2 over 2, square root of 2 over 2. And at 30 degrees, the point is square root of 3 over 2, 1/2. Okay, so we just need to figure out two things. If we do the tangent of 45 degrees, that's y over x. So that's going to be square root of 2 over 2 divided by itself. So that's going to be equal to 1. Okay, so we get the tangent of 45 degrees is going to be equal to 1, so we're going to utilize that in the identity. Okay, then if we look at if we do the tangent of 30 degrees, again, that's y over x, so that's going to be 1/2 divided by x, square root of 3 over 2. So that's going to be 1/2 times 2 over square root of 3. Okay, the 2's are going to divide out to 1. So that's actually going to give us 1 over the square root of 3. Then if we rationalize that denominator, and of course you can do this in your head if you want to, what you end up getting is you end up getting that the tangent of 30 degrees is equal to the square root of 3 over 3. So we're going to utilize that back in the identity also. Okay, so basically everywhere we see 30 degrees, tangent of 30, we're going to replace that with square root of 3 over 3. And everywhere we see tangent of 45, we're going to replace that with 1. Okay? All right, so now let's go ahead and plug this in. So this is going to be 1 minus square root of 3 over 3 over 1 plus 1 times square root of 3 over 3. We're going to have a lot of algebra that we got to deal with in this problem. So I'm going to write this as 1 minus square root of 3 over 3 all over 1 plus square root of 3 over 3, like that. Now, there's two things we have to accomplish. The first thing is we have a complex fraction, so we need to multiply the top by 3 and the bottom by 3. Okay, when we do that, you can kind of do this in your head. You got, and I'm going to write this up here so I'll have a little bit more room for the next step. 3 times 1 is 3, and then when you multiply 3 times the next term, the 3's cross out, leaving the square root of 3. Okay, the bottom works out the same way. 3 times 1 is going to give 3. And then when you do 3 times this expression, the 3's cross out, leaving you square root of 3. Okay? Now, we got to rationalize this denominator, and this is going to require that you multiply by what's called the conjugate. Okay, so we've done this a little bit. So you have a binomial. You have 3 plus a radical, so you have to multiply the top and bottom by the conjugate of the denominator to rationalize that denominator. Okay, so when we do that, it's going to go like this. Okay, first term, 3 times 3 is 9. Outside term is negative 3, radical 3. Inside term is negative 3, radical 3 again. And then the last term, you have a negative times negative is a positive, and you really have the square root of 9, which is going to give you 3, of course. Okay, then if you go to the bottom, first term, 3 times 3 is 9. Outside term is negative 3, radical 3. Inside term is positive 3, radical 3. And then the last term is negative square root of 9. So one thing you've got to be really sharp with on these problems is rationalizing denominators. Okay? All right, so what I'm going to have in the numerator now is I have 9. And see, these two things right here are like terms, so they go together. So that's 9 minus 6 times square root of 3. Of course, square root of 9 is 3. Then the denominator, the inner and outer cancel. That's the reason why we multiply by the conjugate. So notice we're left with 9 minus 3. So that got rid of the radical. So now I have 9 plus 3 is 12. Minus 6 radical 3 in the numerator. 9 minus 3 is 6. Then I just break this up into 2 parts to get the simplified answer of the problem. So I'm going to have 12 over 6 is 2. 6 is cross out. So I'm left with 2 minus radical 3, which would be the final answer to that problem. Okay? All right, now let's do a quick checkaroo and see if this one's right. Okay, so I'm going to move the calculator over here, and let's do this. Since we're dealing with degrees, let's go to degree mode on the calculator. And let's see, we just did the problem tangent of 15 degrees, which is this. And then if I go 2, things not cooperating as usual. 2, there we go, minus the square root of 3 should get exactly the same answer. And we do. So we can verify. Okay, let's move down and try another one like that and kind of see how that goes. Okay. So tangent of 105 degrees. So what I'm going to do on this, the first thing I'm going to do is I'm going to write this as, let's find a combination. The combination that I'm thinking of is 60 degrees plus 45 degrees. Okay, now the tangent identity, I always remember it like this. It's just the sum of the tangents of the two angles. Okay, I always remember that the tangent sum, same sign there. Okay, then that's going to be all over 1 minus, that's a different sign, then it's the product of the tangent of 60 degrees times the tangent of 45 degrees, like that. Now we just need to consider our unit circle and figure out, kind of what the key angles are that we have then. Okay, come on, quit that. Stop that. Okay, let me try that one more time. All right, unit circle. I'm going to put this over here and just look at the two key points that we need to consider on the unit circle. So we have 30, 45, and 60. 45, we're looking at square root of 2 over 2. Okay, and then at 60 degrees, we're going to look at the point 1/2 for x, square root of 3 over 2 for y. Okay, like that. So we need to just work out these two things. So if we're doing the tangent of 60 degrees, that's y over x. So that's square root of 3 over 2 divided by 1/2. So that is square root of 3 over 2 times 2 over 1. 2's cross out. We get tangent of 60 degrees is equal to the square root of 3, which is going to be what we're going to have to utilize in these two parts of the expression. okay? Now we're going to go look at the tangent of 45, which is easy enough to do in your head. It's just y over x. So that's square root of 2 over 2 divided by itself. So that's going to be 1. So the tangent of 45 degrees is going to be equal to 1. So then we're going to go back to our unit circle and we're going to put that in. Okay, I already see a mistake I made. You may have seen that while I was doing this, but this right here should say not 45 degrees, it should say tangent of 45 degrees, okay? All right, so now we're going to plug things in, and the rest of the problem becomes an algebra problem. So the tangent of 60 is square root of 3. Tangent of 45 is 1. Then the denominator, you're going to have 1 minus the tangent of 60, which is square root of 3, times tangent of 45, which is 1. So we have square root of 3 plus 1 over 1 minus the square root of 3. Okay, we don't have a complex fraction to worry about, but we do need to rationalize the denominator on this then. Okay, so I'm going to multiply by 1 plus square root of 3 over 1 plus square root of 3. Again, you're multiplying by what we call the conjugate of the denominator. Okay, now it just becomes a FOIL exercise. So square root of 3 times 1 is the square root of 3, of course. Outer term, square root of 3 times square root of 3 is square root of 9. Inner term, 1 times 1 is 1. And then the last term, 1 times the square root of 3 is the square root of 3. Okay? Now if you go to the denominator, first term, 1 times 1 is 1. Outer term is square root of 3. Inner term is negative square root of 3. Last term is negative square root of 9, like that. Now we're just going to put together whatever we can put together. So it looks like you would have, first of all, that's 3 plus 1. And then square root of 3 plus itself is 2 radical 3. And then the denominator, notice you have a cancellation. And then you have square root of 9 is 3, so you have 1 minus 3. Okay, so I'll move this over here. Looks like we have 3 plus 1, or 4, plus 2 radical 3, all over negative 2. Then we can break it up into 2 parts and do 4 over negative 2 plus 2 root 3 over negative 2. So that's going to give this. 4 divided by negative 2 is negative 2. The 2's cross out here. So that's going to be minus square root of 3. Okay, so that should be the final answer, which is clearly a negative answer. Okay, so if we want to do like just kind of a quick check on this problem, what I'm going to do is, okay, we just did the problem. Tangent of 105 degrees, so I need to make sure I'm in degree mode. That gives a negative answer. Now if we take our answer, which is negative 2, subtract square root of 3, same answer. Isn't that cool? So that's the right answer to the problem, and that's the precise answer. So we're able to get exact values of trigonometric functions that are sums and differences of angles that are derived from special triangles. Okay, now the next page, what we're looking at primarily is just looking at the right side of identity. So one of the things that we have is the sine identities go like this. If you have the sine of a plus b, or the sine of a minus b, they have this structure. The sine of a plus b goes like this. Sine a cosine b, same sign, cosine a, sine b. The sine difference identity goes sine a, cosine b, same sign, cosine a, sine b. See how I'm getting into rhythm when I say that? Sine, cosine, cosine, sine, same sign. Sine, cosine, cosine, sine, same sign. Little musical rhythm there. Okay, so if you look at this, that's a plus sign. So that means it has to match with the sine sum identity. Okay, so that means this is the same as the sine of 10 degrees plus 50 degrees. Okay, the angles are the same. So that is the sine of 60 degrees. Okay, so again, on a unit circle, you would find 60 degrees to have this thing, 30, 45, 60. At 60 degrees, the point on the unit circle is square root of 3 over 2. No, I got that backwards. I caught myself. Let me do that again. Okay, that point on the unit circle is 1/2 square root of 3 over 2. So that means the sine of 60 is the y value, so that would be square root of 3 over 2 would be the answer to the problem. So all that is that's an exercise that gets you comfortable with the identity, and it's nothing more, okay? Then the next problem goes more like this. You have sine, cosine, cosine, sine, same sign. So notice on this, minus, minus. So that means this one has to be the sine identity, the sine difference identity. So this is going to be the same as the sine of 115 degrees minus 55 degrees, okay? So that looks like it's the same thing. That looks like that, again, is the sine of 60 degrees, just like the last problem. So again, that would be square root of 3 over 2. Okay, so again, that's an exercise and getting you comfortable with how the signs go on the identity is all that is, okay? All right, now if we go to this one, the tangent identity works like this, okay? Now we have two forms of the tangent identity. So if you have the tangent of A plus B, the identity goes like this. Tangent A plus tangent B all over 1 minus tangent A, tangent B. So notice that in this problem, these signs match this identity. So this means this is going to be the tangent sum identity. So this is going to be the same as the tangent of 5 degrees plus 25 degrees. So that's the same as the tangent of 30 degrees then, okay? So if you looked at a unit circle, actually let's do this just a little differently this time. So if we did like a triangle, why don't we just do it like this, just for something totally different, okay? Don't forget about these triangles because they come in handy. So let's say this is a 30-60 right triangle. And opposite 30 is 1, opposite 60 square root of 3, and that's 2. So if we were doing the tangent back on this, that's really opposite over adjacent. So if you look at a 30-degree angle, opposite is 1, adjacent is square root of 3. So you'd have 1 over square root of 3, and then that would rationalize to square root of 3 over 3 as an answer to the problem. You could also look that up on the unit circle and do y over x if you wanted to. So that's what the answer to that problem would be. Okay, moving on. I'm going to give you guys a few minutes here to go ahead and work number 9 and 10 out, and then when you're done, you can resume the playback and see if you got. Okay, so here's what you should have come up with on this. Now, the thing on this is, since this is a plus sign, that means that this is the sine sum identity. So it's going to be the sine 20 plus 100, okay, because it's the same sign. So that's going to be the sine of 120 degrees. So we're just going to consider a unit circle on that again and look up 120 degrees. Okay, so on a unit circle, 120 is a quadrant 2 angle that corresponds to this place. Okay, so on the unit circle, the x value is negative 1/2. The y value is big, so square root of 3 over 2. Okay, so if we're doing the sine, we're looking at the y value on a unit circle. So that will end up being square root of 3 over 2 as a result to the problem. Okay, all right. I do want to show just something really kind of quickly on the calculator. It's not all that necessary you check on here, but it's kind of a worthwhile thing maybe to do just one time here. So if you took the original problem, which says sine of 20 degrees times cosine of 100 degrees plus cosine of 20 degrees times sine of 100 degrees, and you're in degree mode, that gives this. Well, if you take the answer, which is square root of 3 over 2, Same thing. So like if you were doing a quiz on My Math Lab, okay, I think you could check with your calculator, couldn't you? Make sure you're right. It's a worthwhile thing to do if you're not confident. Okay, all right, next problem would be done kind of like this. The key is that that's a minus sign. So what that means is this is going to be the tangent difference identity because of that. So this is the tangent of 155 degrees minus 35 degrees. So that is the tangent of 120 degrees, which is kind of nice because we already have 120 degrees up here. So if you look at the diagram in my unit circle, we have y over x. So what we'd really do on this problem is we would just have to do y over x, which is square root of 3 over 2, divided by negative 1/2. You are going to get a negative answer. So this is square root of 3 over 2 times negative 2 over 1. Of course, that's going to divide the 2's out, and that will leave you with an answer of negative square root of 3. Okay, like that. So that's what the tangent of 120 degrees is. So that you can use that identity to get that. Okay, now, number 11, a little bit harder problem. This is more of a analytic problem to kind of help you learn your identities a little bit better. So you're actually given two things. You're given two angles. You're given the cosine of A as a third. You're also given the sine of B as negative 1/2. You're given A as in quadrant 1, B as in quadrant 4, and your job is to find the sine of A minus B. Okay, so if you're going to find the sine of A minus B, the very first thing that you want to do is pull out the identity. So the identity goes like this. It goes sine of A times cosine of B, same sign, then backwards, cosine of A times sine of B, like this. Okay, now we've been given a couple of things. Okay, we've been given the cosine of A, so we know that. We've also been given the sine of B, so we know that. So those two things are already given in the problem. So that's going to get replaced with 1/3, and then the sine B is going to get replaced with negative 1/2. So the problem is you've got to figure out what the sine of A is and the cosine of B is. These are the two things that you must figure out to solve the problem. So what we're going to do is we're going to do a couple of diagrams on this. So to begin with, let's just work with angle A for a minute and see what we can figure out. So angle A is in quadrant 1, so we know that. We also know that the cosine of A is equal to 1/3, which tells us x is 1 and r is 3. Okay, so our angle A is a quadrant 1 angle. So we can draw a reference triangle for this where x is 1, r is equal to 3, and then we could find y by doing the Pythagorean Theorem. Okay, so let's just do that. We have x squared plus y squared equals r squared. So that is y squared equals 9. Hold on. Getting a little ahead of myself here. Okay, so what we're going to have here is we're going to have y squared equals 9 minus 1, or y squared is equal to 8. Okay, you can take square root of both sides, so you're going to get y equals plus or minus, and then you want to go ahead and break that down, so you get y is plus or minus 2 root 2. Now, since you're in quadrant 1, we know that y is positive in quadrant 1, so that will give us 2 root 2 like that. So that means if we're doing the sine of A, the sine of A is y over r. So that means that in this piece of the problem right here, you're going to have 2 root 2 over 3. So that takes care of that. Okay, now I'm going to look at angle B to figure out what the cosine of B is. So I'm going to draw an angle diagram on this for a different angle. This time angle B is in quadrant 4. So when we do this, we need to draw just a picture of a quadrant 4 reference triangle. And again, you were given on this the sine. You were basically given the sine of B, which is this angle, is negative 1/2. Okay, now the sine's definition is y over r, so that means r is 2, y is negative 1, and then this is a 30-60 right triangle. Okay, so that means this x value has to be square root of 3. If you don't know that, you go to the Pythagorean Theorem. So now what we got to do is we got to do the cosine of b. So the cosine of b, looking at this angle, b, would be the x value over the r value. So that means that's going to be square root of 3 over 2. Okay, so I'm going to replace that with square root of 3 over 2. Then we're ready to crunch this out, okay, and get the answer. Okay, so when we multiply this out, multiplying this fraction out, you're going to have 2 radical 6 over 6. And then when you multiply this out, that's going to give 1/6. You have a negative times a positive, or sorry, a negative times a negative is a positive. So you'd have 1/6 like that. And then if you put this together, you're going to have 2 radical 6 plus 1 all over 6 would be the final answer to that problem then. So we're finding the sine of a minus b. So that's the answer of the problem. All right, now one thing I usually like to show on these problems a little bit is your calculator can be used to make some sense out of this problem. It can even be used to check your answer on this problem if you so desire. If you take the cosine of a is 1/3, so if you did inverse cosine of 1/3, you're going to get this angle. And the problem did say that you're in quadrant 1, so that is your angle A. The sine of b is given as negative 1/2, so if you went inverse sine of negative 1/2, this is going to give you a negative 30-degree angle. Remember, that was a 30-60 reference triangle anyway. So what we're doing on this is we're really doing a minus b. We're doing the sine of a minus b. Okay, and I'm going to go ahead and just put this in like this so we can do the sine of a. And I'm going to put in like just all the decimals, 70.52877.937. Then I'm going to subtract. Now I could either say minus negative 30 or I could say minus 330 because 330 degrees is really the quadrant 4 angle there. And I'm going to get this answer. Okay, now if I took my answer, and I'd have to go like this, parentheses, I'd have to go 2 times square root of 6, close parentheses, plus 1, close parentheses, divide by 6. I get the same answer. It's amazing. So again, you can use these calculators to check everything. Okay, so good problem to check on your calculator. You want to do this analytically, of course. You don't want to just pull out your calculator because you're just a button pusher if you're doing that. So that's how that would work out. Okay. All right, very good. Now let's go to a couple things on the next page and see kind of what we get on this next page here. I think we're just going to do a couple of identities. These problems are fairly easy to do, so we're going to take the sine of alpha plus 2 pi. So we're going to use the sine identity. And the sine sum identity goes like this. It's the sine of the first angle times the cosine of the second angle. Same sign, so that's plus. And then you do it backwards. You do the cosine of the first angle times the sine of the second angle. Real simple problem. So the idea is if you were dealing with a unit circle, 2 pi is 1 lap around the circle. So you're looking at the point 1, 0. So basically, the cosine of 2 pi is 1. The sine of 2 pi is 0. So you just put those things in, and then we just kind of see what happens here. Okay. So what we're going to get then is we're going to have sine of alpha. Cosine of 2 pi is 1. Cosine of alpha. Sine of 2 pi is 0. So you end up with sine alpha times 1, which is itself, plus 0. So that's equal to the sine of alpha, like that. So one of the things I want you to notice on this is if you thought of this in a graphical context, 2 pi is the period of a sine wave. So if you add a period, you should get the same answer, and you do. So that's very logical. If you actually graphed the sine of alpha plus 2 pi, you'd have a phase shift to the left of 2 pi, so you'd have the same result. Okay? All right, next problem, we're going to use the tangent sum identity, which goes like this. So we're going to say tangent of alpha, since that's a plus sign, we say plus tangent of the second angle. And then the denominator, we say 1 minus the product of the tangent of alpha times the tangent of pi. Okay, like that. All right, now we're going to look, again, just at a unit circle, look at pi. So if you have pi on a unit circle, you're looking at -1, 0. So the tangent of pi is y over x. Y is 0, x is -1. That means the tangent of pi radians is 0. So everywhere you see a tangent of pi, you're going to replace that with 0. So that's going to leave us with tangent of alpha plus 0 over 1 minus tangent alpha times 0. So that's going to leave us with tangent of alpha in the numerator over 1 minus 0. So that will just leave tangent of alpha over 1, or that's equal to tangent of alpha, would be the final answer. Okay, so tangent of alpha plus pi is equal to tangent of alpha. If you think of graphing, this should make perfectly good sense. The period of a tangent is pi. So all this is just saying if you take an angle and add the period to it, you should get the same answer, and you do. So both of those problems can be interpreted pretty well graphically speaking. Okay? All right, so to finish this up, I'll let you all do the next two problems, and then that'll close off the lesson. Okay, so here's what you should have done on this problem. You're going to use a sign difference identity, so you should have done the sine of alpha times the cosine of pi over 2, same sign, and then do it backwards. Do the cosine of alpha times the sine of the second, like this. Okay, so we need to work out two things. We need to work out the cosine of pi over 2, and we need to work out the sine of pi over 2, which is nothing more than unit circle stuff again. So pi over 2, you would be looking at the point 0, 1. Okay, so that's going to mean that the cosine of pi over 2 is 0. The sine of pi over 2 is the y value, so it's 1. Just plug in and see what you get. So this is going to be sine of alpha times 0 minus cosine of alpha times 1. So that's going to be 0 minus cosine alpha. So the answer should be negative cosine alpha. So we just showed that the sine of alpha minus pi over 2 is the same thing as negative cosine alpha. If you graphed those two things, they'd have the same exact graph on there. And I'm going to show this on the calculator just because, I got a little time to do that. If I was to go through, I haven't showed this yet, but if I was going to put myself in radian mode, this doesn't really constitute a proof, but it demonstrates it graphically. So if I went to y equals, first thing I need to do is change this back to function mode. Okay, I'm going to do that. So if I put in y equals sine, instead of alpha, put x minus pi over 2. That'll have a graph. Okay. Now I'm going to leave this blank for now, and I'm going to set up the window. And I'm just going to graph this like from 0 to 2 pi, just over a period. Scale maybe of pi over 2. And let's see, y minimum, whoops, I didn't mean to do that. Pi over 2 for that. And then let's go -2 to 2 maybe. Like that, and here's a graph. Okay, so that's the graph of the sine of alpha minus pi over 2. It's been phase shifted, so that 0.00 is phase shifted over pi over 2 to the right, like this. But I want to show you something. If I press y equals, now if I put in what we got as a result, negative cosine of x, let me show you what happens when I press graph. It's just going to graph the same thing because they're the same graph. Now that doesn't prove anything, but it demonstrates that they're probably the same graph, and they are. Okay, so that's kind of a cool thing to show students on a calculator too. Okay, and this last problem, you should have done this. The tangent difference identity goes like this. It's tangent of the first minus tangent of second. Then it's all over 1 plus, that's a different sign. Then it's the product of the tangent of alpha times the tangent of 360 degrees. Okay, again, if you look at a unit circle, 360 degrees is 1 lap, corresponding to the point 1, 0. So the tangent of 360 degrees is y over x. So that's equal to 0 over 1, which is equal to 0. Okay, so everywhere we see tangent of 360, we're going to replace that with a 1, or with a 0. So we get tangent of alpha minus 0 over 1 plus tangent of alpha times 0. So that means the numerator is tangent of alpha, the denominator is 1 plus 0, so the answer is tangent of alpha. Okay? All right, and that will close that off graphically. That kind of means the same thing. 360 is actually 2 periods of the tangent, so you would expect to get the same answer and you'd have the same graph. Okay, so that will close off this section. Hopefully this helped everybody to learn the information and put a happy face. Keep smiling. It's only trigonometry.